All right, this video is for day 3 and day 4 when it comes to finding the volume of a pyramid and the volume of a cone. All right, now probably one of the easiest ways to explain this is that the actual idea of the volume of the pyramid is directly related to the volume of a prism. Okay, now we did that volume of a prism one earlier, but what I really want to show is kind of like an idea. These two are related to each other, I say versus, because they are similar kinds of shapes. And the best way to really understand this is kind of in a visual way. So one of the ways I'm going to show this, and I'm just going to show you a video. This is kind of what I would normally do in one of my classes if I was going to try and show the relationship here. Now this is a video demonstrating this particular idea. And once we get through it, you'll be like, oh, I get the idea. It's really not that big a deal. What this person is doing is he comparing a prism shape, rectangular prism, that's just like this one right here, and a square-based pyramid. Now the two of them are basically the same, and he took the inside of the fillings out, and what he's going to do is he's going to fill up one of these pyramids and show you that if he fills it up with water, it looks like green gooey water, okay, and pours it into the prism, that it turns out that it's going to end up turning out to be how many of them that it will take to fill the actual prism up. So he's already done 2, and it turns out to be exactly 3 pyramids that it takes to fill the exact same size prism. Okay? Now this doesn't work in just square prisms. It can also work in a triangular prism and a triangular pyramid just as well. Notice that the bases are the same deal. The heights are exactly the same. So they're the same height is what's going on. And if you fill them up with liquid, which is going to be about volume, it's going to take how many of these triangular pyramids to fill up that triangular prism. There's one. And then we're going to do a second one. And then finally, if we do a third one, and this one really gets kind of close. Let's check this out. Whoa, and it barely hangs on. So it is technically 3 of those pyramids are fitting inside of that prism. It's pretty neat that it doesn't matter what shape the base is, as long as the bases match and the heights match, you're going to be okay. Now check it out. The heights match these two, cylinder and cone, and then it would be the same base size. How many of those cones would actually fit inside that cylinder? And he's going to fill this up. It looks like with oil. Ooh, that's disgusting. Okay, some green, nasty, liquidy stuff. And 2. And this one right here. It may not be exactly perfect, but it does turn out that it's going to be 3. And he tries to hide the rest. But it's 3 that are going to fit inside there. Now the key is that they have the same base and they have the same height. Okay, so with that basic idea being said, let's kind of talk about this. If I was going to talk about this pyramid in terms of its particular volume, its volume would be really relatable to the prism, which is the base area times how tall it is, but instead of actually saying it's a full entire prism, it's only a third of it. And that's your basic formula of what's going on. Now, to actually figure this out, you're going to have to make sure that you identify some really important pieces. Number 1, you got to make sure that you find the base, and that's this piece down here at the bottom. Now, a lot of the ones that are in our notes are rectangular bases. So remember that we're going to have to find that length or that area by doing length times width to figure out that concept. That's going to take care of this piece. Then you're going to need to multiply by the height of the pyramid, and the height of the pyramid goes straight up through it. This is the height of the actual pyramid. Okay, so the height right there in green. Be careful, they may actually give you other kinds of heights that can be useful, but not necessarily in the formula, and that would be this height over here, which is down straight along the side. That's called the slant height. Now, the slant height doesn't go specifically into the formula the way that it should, but it does end up being useful if you have this dimension and the slant height, which is L, and the height, you could actually use Pythagorean theorem to help you solve for the height. So be aware, they might actually do that, and we'll have to figure out what's going on. This works on a regular pyramid, and as we said, the volume of a pyramid is going to end up being the base area times the height, which is regular for Prism, and then you just cut it in by 3. That's the deal. Now, let's try a couple of these problems to see what's going on. Okay? First piece says, help me find what base we're talking about. Well, we're talking about a base that's a square in this case, and that base is 6 by 6. So if I plug into that formula that I had up above, and I'm just going to kind of roll up here, the volume of that pyramid would be 6 by 6 for the base area, times how tall is the pyramid, which is 5, and then I would take that answer and I would divide it by 3. Okay? And an answer that would look just like that. Let's see if we can come up with an answer for it, which is 6 times 6 times 5, and then take the answer and divide by 3. And the answer would be 60 feet cubed. And that's how big that particular pyramid is. So pretty simple. If you've done some of the Prism stuff, you ultimately will be able to get the pyramid pretty easily. The base in this case, again, is a 10 by 10 deal. So that's going to be the base is 10 by 10. And as I start to write the formula here, I'd be like, oh, 10 times 10 for the base, but then I'd go times the height. Now, this one right here, they're denoting that this length right here is the 13. That's the slant height, which they call L, but it's not the actual height itself. That's on the inside. So we'd have to draw a triangle out of this, and I'll have an interior triangle on the inside there. This is 13, this is H, and this distance would be half the size of the side length, which would be 5. Now that's a Pythagorean triple, or Pythagorean theorem, if I wanted to figure it out that way. And it turns out to be a Pythagorean triple, which makes H equal to 12. That's the number that'll go inside here. So it had a little side work that you had to do before you could come up with it, and then we would divide the answer by 3. So 10 times 10 is 100 times the 12, and then I would take that answer and divide by 3 is what it'll end up turning out to be. That would be 400 meters cubed. Okay? Nothing really tough there. Just watch that they're either giving you the height or they're giving you the slant height. Now, you can do the same formula, not just necessarily in regular pyramids, but you could also do it in shapes that the bottoms are a rectangle. So the bottom is a rectangle, which would be 10 by 8. That's your area for the bottom piece. So the area is 10 times 8 times how tall it is, and they did give you the height here, so that's times 6 divided by 3. We've got, what, 80 times 6. Let's see what kind of number we come up with on this one. 80 times 6, and then take that answer and divide by 3. Don't forget to divide by 3. That's the key to what separates the pyramid from the actual prism. Okay? Now, number 4, the last one that's listed here, it says, what is the actual height? Now, they're not going to give you the height. They're like, the height is unknown, but the square pyramid, and that's important to say here, the square pyramid has a side length of 12. So it's 12 by 12 here, and it ends up having a volume of 240 square or cubic feet. Now, if I write that formula out, I would put the 240 on this side, and I would put the 12 by 12 here for the base times the height, which I don't know, and I divide by 3. So we're looking for an unknown that's on the other side. Now, to solve for that unknown, we're going to have to make sure we get rid of each one of these dimensions the correct way. Maybe multiply it by 3 to remove this division, and I'll end up getting 240 times 3, or 3 times 240 here, is equal to 12 times 12, which is 144h. And to remove this guy, I would divide him on the other side, and I'd end up with what h is equivalent to. Now, let's see what we come up with here. That's 3 times 240. And then take that answer and divide by 144. And I'd get an answer for the height to be 5. So you can actually solve for other individual dimensions as long as you can fill out your formula with where the correct things go. Now, the reason why we conclude day 3 with day 4 is because the cone has the same similar concept. The cone is related to the cylinder. Now, the cylinder's formula is pi radius squared times height, but it takes how many cones to fit in the cylinder? It takes 3 of them. So ultimately, the volume for a cone is going to be pi radius squared times height divided by 3, because it's 3 of them. Now, again, you're going to end up having a couple of things you got to watch for. The base, which is going to be a circle, that's going to be a pi r squared circle, so that's not going to be too bad. You may actually be given the slant height. Remember that that's not as useful in the formula, but it could be useful in helping you find the Pythagorean theorem to find the height. And then last but not least, the height is actually right here, and that's going to be the h value that you're going to plug in the formula. Now be careful. This guy's the height, this is the slant height. This distance right here, the one that's labeled in green, happens to be the radius. And we have a Pythagorean theorem there that we could use with the slant height being the hypotenuse. So be careful, that's going to be our Pythag if we need it. All right, now let's try a couple of them in terms of finding their individual volumes. They're pretty much easy to plug into. Remember that that volume formula is volume of a cone is pi radius squared times height divided by 3. So if I just plug this guy in, I would end up having pi times the radius, which is 4 squared, times how tall is it? They are giving me the height is 9, and I divide by 3. Now, this comes in kind of 2 stages. One, find the answer without the pi first, because they may end up having certain questions on exams where you might have to find it without pi. So 16 times 9, that would be the top 2, and then take that answer divided by 3, and this answer would be 48 pi. Hold on just 1 second. All right, so that was my brother, and he completely confused me in what I'm doing on. So ultimately, I did all these numbers right here and came up with the answer in terms of pi. Then I would take that answer and I would multiply it by pi, and I would come up with the approximation answer, which is 150 point something. Boy, that went away fast. 150.8 centimeters cubed. All right? So, relatively easy concept when it comes to the volume of a cone. Let's try this next guy again. So, volume of this cone is going to be pi radius squared times the height divided by 3. Now, I left these things blank because I want you to start thinking about what kind of numbers we're going to put in there. Now, if they show you an entire length at the bottom, that is a diameter, which would mean the radius should be 2.5. Put 2.5 in the right spot, 2.5 right there. Height is shown, that's 10. We are ready to rock and roll. Let's do some mathematicus. So we've got 2.5 squared times 10, and then I would take that answer and I'd divide it by 3. This would be the answer in terms of pi, so it'd be 20.83 repeating pi. And that would be the exact answer, and I would push that times pi to get the estimate. So in this case, the estimate is 65.4 feet cubed. Pretty straightforward concept. Just do pi r squared times height, divide by 3. Number 3 and number 4, little food manufacturing questions, selling yogurt in the cone shape. How much yogurt does it actually hold? Well, that is a cone, so I'd say here that the volume of that cone is going to end up being pi times the radius, which is 7 squared, times the height, which is 22 in this case, divided by 3. And how much should it end up holding? Well, let's find out. We don't probably want a pi answer here. We probably want to end up getting an actual answer because it'd be in like ounces or something like that. So 7 squared times 22 divided by 3. The pi answer is 359.3 pi. And the approximate answer would be times pi, in this case. Oops, not that. Let's delete that. Times shift pi. And my answer would be 1128.9 centimeters cubed. Estimate, exact. All right. Now, last one that we've got here, it says the cone has a volume. Now, they're already giving you a volume in this particular case, so that piece has got to show up on this side of the equation. And then they give you the radius of the base is 5, so pi radius squared, or 5 squared, times the height, because I don't know it, divided by 3. Now, this whole entire one is more about the algebra than it is about the geometry, how we're going to remove things based on where they're at. I would multiply each side by 3 to remove the 3 on the bottom, and I get 900 is equal to 25 pi times h. And if I divided each side by 25 pi, I would end up with what h's value turns out to be. That's 900 divided by 25 pi. Let's see what we get here. 900 divided by, I'm going to put this in parentheses just because it makes sense to divide by it as a combination, and it'll be 11.5 is how big the height is. It should be, in this case, meters. All right? Now, here's the deal. You want to go through each one of these. Make sure you understand them all. But more importantly, give that homework a try and try the pyramid and the cone. The key is divide by 3, ladies and gentlemen. Everything is divide by 3.